Imagine a world where ultra-fast levitating trains zip between destinations. The Sahara Desert was covered in solar panels that could power homes in slums. Alright, hold up. You're probably thinking, Olishba, you're being really optimistic here. But this is actually a future that is closer to us than we think, thanks to a field in nanotechnology called nanomaterials and superconductivity. But the star of the show is graphene. Current production of electricity actually wastes a lot of energy, and it's also unstable to carry it into larger distances. Using superconductivity, we can create high voltage and high efficiency. Graphene is a material which is made up of a bunch of carbons put together in the shape of hexagons. This landscape allows electrons to behave in unusual and really exciting ways. Atoms in the same graphene sheet have a very strong bond, and atoms in different sheets have a very weak bond. This is why it's so easy for us to just create large single sheets of graphene and then layer them on top of each other. If you rotate one graphene sheet in respect to the other, you could actually create something called a moire lattice, which is basically just a periodic pattern that forms within the twisted layers. The moire lattice creates a new landscape for electrons to move through, making it possible for us to actually fine-tune them at the atomic level. Electrons react very sensitively to minor changes in the twist angle between graphene sheets, giving us the ability to basically induce superconductivity, which is the most powerful form of electrified conductor because it has zero electrical resistance. If you rotate the material's layers, you can create a phenomenon which would otherwise be considered impossible. It's kind of like cloaking, which is a search engine optimization technique in which the content presented to the search engine is different than that is presented to your browser. For example, let's say that be Google. This is so crazy if you think about it, because these graphene superconductors can be used for solar power, nuclear reactors, and even high-speed trains. We can do this by packing the material even tighter by keeping it at a consistent temperature. A future where we can get sustainable energy to everywhere in the world might be closer to us than we think, all thanks to graphene.